Okay, nice easy chromatography question to get us started. First bit, over here. Give a reason why the start line is drawn in pencil rather than ink. Okay, so here's our piece of chromatography paper. You draw a line in pencil here and you put the dot of your mixture of inks or whatever they are on the line. Now, you always draw that line in pencil because pencil lead, which is graphite, it's just carbon, it's insoluble in water. And it's insoluble in practically every solvent you can find. Okay, so the correct answer is pencil is insoluble in the solvent. Okay, because what you don't want is when you put it in the water and the waterfront moves up and it drags various ink dots with it, you don't want it dragging the pencil line as well. That has to stay exactly where it is. So you want it to be insoluble. Okay, right, we have to complete this diagram for the next question. So, having drawn your dot on the piece of chromatography paper, you then put it inside the beaker, which has some water or whatever solvent you're going to use in the bottom, and you usually have a piece of card or something on top. So you lift the piece of card and you put the chromatography paper inside, and then you put the card back and leave it. And after a few minutes it'll look like that. So you have to draw this in the correct position here. The key when you do this is to draw it so that the pencil line is above the level of the solvent. Okay, that is very important. So that is how you should draw it. Okay, you have to get the dot, which is at the same level as the pencil line, above the level of the solvent, because when it's dipped in the solvent, the chromatography paper draws the solvent up through the paper. So it has to start moving and then hit the dot and then start dragging it. If you draw it like this, now this is wrong, okay? This is the correct way. If you draw it like that, okay, that is definitely wrong. Then the water or the solvent will still move up the chromatography paper, but it won't drag the ink dots with it. They'll just spread out and dissolve in the water, sort of through the paper. It'll be a mess, okay? So that is definitely wrong, and you want to do it like that. Get the pencil line and the dot above the level of the water, okay? In the exam, it's fine drawing it like that, but what's holding it up? And in reality, what you would do, you'd have your beaker like this, okay? You'd have your level of water, or whatever solvent, and you lean the card against the side like that, okay? This is looking at the card, the chromatography paper, from the side on, okay? And the pencil line will be about there, and the dot would be sort of on the surface. Again, this is looking at it side on, okay? I'm just saying that in reality, it doesn't magically hold itself in midair. It has to rest on the bottom of the beaker, right? But the important thing is that the pencil line and the dot are above the level of the solvent, okay? But just drawing it magically suspended like that for the exam is okay. Okay, so I like to stress that that's side on. All right, what's next? Okay, so here are the results. You come back a few minutes later, the solvent has moved up to this level here, and it's separated out the dot into these two dots here. And we have to calculate the RF value. And they even tell you what the RF formula is. You don't have to remember it. So the RF is the distance that the dot has moved. So the dot distance divided by the solvent front distance. Okay? You really should remember that. You shouldn't need to be told it in an exam. Okay? So remember it now. But this is the first easy question to get you broken in nice and gently. Okay, so the dot distance, they're interested in the blue dot. We're told that it's 14.5 centimetres and the solvent distance is 15.3 centimetres. We don't have to bother converting to metres because it would cancel out whatever changes we make. It's one distance divided by another, so it's a ratio. We're just going to get a number. We can leave it in centimetres. Stick it in your calculator and you get 0.947712 something something something, and they want it to two significant figures. So that 7 pushes that 4 up to a 5. So that's 0.95 to two significant figures. Easy. Okay. Right, so now we have this jobby here. It's just the same thing, it's just a wide piece of chromatography paper with 4 different samples on it. Okay. Which mixture contains an insoluble food colouring? Okay, so the 4 samples of food colourings. Right. The experiment's over, okay, this is the results. The solvent front's moved up to there, but Q still has a dot there on the pencil line. Any dot that hasn't moved at all, that's still on the line, is insoluble. So it's that one. That has an insoluble component in the dot mixture. Okay? Give a change that could be made to the experiment to obtain an RF value for the insoluble colouring. Okay, now this dot didn't move because it wasn't insoluble in whichever solvent we used in our beaker. Okay, but whatever that dot is, it may be soluble and therefore it may move up the paper if we use a different solvent. So that's the answer. Give a change that could be made, just use a different solvent. You're not expected to suggest one, but you could say ethanol, maybe. Water, ethanol, but yeah, you don't have to suggest one, just different solvent, okay? Okay, good. Right, explain by referring to the figure which mixture is separated into the greatest number of soluble food colourings. For 2 marks, okay? Well look, it's clearly S, right? So you don't just write down S, you have to somehow get a second mark out of this. So just say the obvious to get all the marks like I keep banging on about. So yeah, firstly, it's S, and the reason is, saying the obvious, S has the most number of spots. Okay, S has 4 spots, and the most the other have is 3. Okay, the insoluble one doesn't count. So Q has 3, P has 3, R has 1. That's it, 2 marks. There we go. Nice, easy chromatography question.